Hello, and welcome to a digital lecture for Salt Lake Community College. This lecture will cover section 3.3 for Introduction to Statistics, applying the normal model. There are only two ideas presented in this section that we would like to be comfortable with. The first is the definition of the standard error. The standard error gives the variability of point estimates from sample to sample, which is equal to the standard deviation associated with the estimate. We can use the z-score in a hypothesis test. In the context of a hypothesis test, the z-score for a point estimate is calculated as your point estimate minus your null value divided by your standard error. The z-score will tell us how many standard errors the point estimate is from the null value. Notice that if z is greater than 0, it means our point estimate is above the null value. And if your z-score is less than 0, it'll mean that your point estimate is below the null value. Again, note that the standard error in this case is equivalent to the standard deviation of the point estimate, and the null value comes from the null hypothesis. Let's look at an example of how we can apply this. In the head-turning case study from Chapter 2, the hypotheses were the null hypothesis that the proportion is equal to 0.5 versus the alternative hypothesis the proportion is greater than 0.5. In the case study, we were given that 64.5% of the 124 couples observed turned their heads to the right when kissing. The standard error is given as 0.045. Let's compute the z-score for this hypothesis test. So notice your z-score is going to be your point estimate minus your null value divided by your standard error, where your point estimate is given as the 64.5%. Now, when you enter this in your calculator, you're most likely going to need to insert parentheses around the numerator. Now, since all of our calculators are probably different, please verify that you get the same value as me. I think you should get approximately 3.22, where I've chosen to round to the second decimal place. Now, how many standard errors from the null value was the sample proportion for the head-turning case study? The interpretation of the z-score tells us that the sample proportion is approximately 3.22 standard errors above the null value. Let's look at another example. In the medical consultant case study from Chapter 2, the hypotheses tested were the null hypothesis, the proportion is equal to 0.1, versus the alternative hypothesis, p is greater than 0.1. In that case study, 4.8% of the consultant's 59 clients experienced complications. The standard error is given as 0.028. Compute the z-score for this hypothesis test. Now this is where I would like to ask you to pause the video for a minute while you calculate your z-score. After you've calculated your z-score, please unpause the video and let's verify that we get the same answer. I'll see you in a moment. Okay, I hope you paused the video and calculated your z-score. You should have been looking at your point estimate minus your null divided by your standard error. Remember, your point estimate was the 4.8%, and the null value is given by your null hypothesis. Also recall, when you enter this in your calculator, you're most likely going to need parentheses to group the numerator. I'm hoping you're able to confirm that this point estimate is 1.86 standard errors below the null value. And it's below because of the negative value of the z-score. So our interpretation, the sample proportion is approximately 1.86 standard errors below the null value. That about covers all the definitions for section 3.3. If you have further questions, be sure to review the example videos that follow or ask your instructor.